Okay. Right. So welcome to this series for the pluggable resource management, the container compute interface driver extensions. Just wanted to give today a short update where we are with the CAP definition. So basically, in the last days, we were updating the CAP definition based on some of the feedback what we got some sessions back. And now this is on a branch. Most probably we will push it to our master thing and today, and it will be ready for another scan from the reviewers when you have time. But just to go through some of the key things what we changed. So summary is more or less similar as what we had before. Motivation also remains untouched a lot. So the new stuff are starting, or the changes start from the compute specification options. They are as suggested by the group. We basically decided to pick one option. We had listed 3 options and one leading option based on the dynamic resource allocation claims. This we describe it a little bit in more detail. Currently, the example there, we provide an example, and it's based still on a JSON kind of config map, not using CRDs, but I'm mentioning that CRD is an option for specifying that. So in the example, we have first how you can use that or how you can use the attribute-based API through a claim mechanism, which is nothing changing actually to the classical DRA specification type. A little bit more details follow here, which specifies how such kind of config map, or basically what's the format of the JSON, what we were thinking to, or on the attribute-based API, which was asked several times, what is expected to be seen there. So basically we give some definition of possible attributes, and we are thinking basically to have a core list, which is specifying how many cores you want to request for. They can be a static number of cores, or it can be a range. Most probably for alpha, we will not support ranges. Ranges are a little bit in the, if you think about burstable quality of service. So if you want to spawn a container which can burst between 1 and 4 cores, we can pick basically a CPU set with 4 cores and have shares which allow the container to burst between 1 and 4. But yeah, this is currently out of scope for alpha. The ranges, we will stick just to fixed number of requested cores. Then for each kind of entry, we have corresponding attributes. So you can have device affinity attributes, which are basically requiring some device affinity, or trying to get some device affinity, or not required. Similar for memory, basically requiring NUMA affinity. Bind is basically similar to single NUMA, or interleaved is similar to some sort of NUMA spread kind of semantics. Later, we think to add also attributes for huge pages and stuff which will be needed for better kind of specification in terms of memory. Then we have also some CPU attributes which control isolation and siblings scheduling, basically exclusive shared isolation levels. Basically, you can get exclusive core similar to what the static CPU manager does with guaranteed quality of service. Shared is basically you get a CPU set which can be shared with other pods containers. Then core sibling required denied. This means basically if you want or if you have if you're requesting for certain amount of cores, they will try to use the logical cores on the same physical core. So sibling required is this option. Core sibling denied is if you have basically if you want to take one of the logical cores and block the other logical core from being used from other pods. So this is core sibling denied. There are some applications which want to take the full physical core for themselves. So that's this case. Then there is an option basically preferred, which is trying to get the logical or trying to get logical cores which are on the same physical core, but this is not a must. Right, this is the a little bit addition to the cap. Then further additions are following here in the architecture section. We removed a little bit before. We were mentioning that we were not sure how to associate pods and drivers. Now we mentioned that we will use the resource class of DRA for that. And CCI resource manager basically will be using another path for the registration of drivers var run CCI. Which is not to have conflicts with DRA, basically, which is running under var run DRA. So you can have basically drivers with the same name between the two. Basically, they will be, one will go in under var run CCI, the other one will go under var run DRA, and you will not have.
Sorry, one second. What is this for? So the things under var run CDI are just the CDI specs. The plugin registration and everything happens under the. I'm talking about for DRA. The plugin registration happens under the standard plugin directories in var kubelet plugins.
Oh, you're right. So basically, but after that you are sending or you're creating the entry points to the plugins in var run DRA. Was it like that?
No, there's no var run DRA. There's var run CDI, and all that's in there is the CDI specs. Everything with with kubelet registration and the sockets between the kubelet back and forth to the plugin all happen in the standard plugin directories, which are at var run kubelet, or I forget what the exact path is, but it's something underneath.
And there you get DRA.socket or basically in var run kubelet you had the DRA.socket or something where the registration.
That's right. I mean, there's two sockets that are created. One is for the connection, for the kubelet's connection to the plugin, and then the one from the kubelet, from the plugin to the kubelet. And there's two separate directories. One directory is called plugins, where you create a DRA specific, a driver specific directory for each of your individual drivers. And then for the reverse connection, it's under the plugin _ registry directory,
right,
which is how CSI plugins and all other plugins to the kubelet.
Yeah, I remember in my prototype I did basically unique location for the CCI stuff so that they don't get mixed with the DRA. Maybe I mixed the paths here. Something I will double check that it might be wrong. But yeah, the point is here I have a unique path to the socket, not to use the DRA kind of socket, but have a CCI socket so that for the registration, so that those two are not mixed, more or less. I will correct that. I will double check it, make it correct. The other kind of addition was on the scheduler side. I was looking a little bit to the Kubernetes scheduler. There is this kind of kubelet provides so-called node listener, or I have actually the code here, which would be interesting. Just to find the right editor. So yeah, there is this kind of hot resource server part of kubelet, which is responsible to expose available CPUs, available devices, available memory to the scheduler. Scheduler takes those values or asks each node for those values through this listener, more or less. So I added some clarification that if we want to provide, or we have to provide correct information about what are the allocatable CPUs and the allocatable memory, at least for long-term beta release, where we want to coexist with static kind of CPU management and stuff like that. So basically, those we have to add a functionality which where the CPU provider get allocatable CPUs is calling CCI manager to get allocatable CPUs and memory. Before, this was calling basically CPU manager. That would be one thing we have to enable for CCI, so that scheduler knows what are the allocatable CPUs, allocatable memory.
And there is also another endpoint, which is the list, which is answering letting the caller knows which resources, so in this case, CPUs are currently allocated. So yeah, totally get allocatable, also the list endpoint.
The list, yeah, I think there are two functions. Yes.
Okay.
Yeah, so I mentioned in the cap the component name, hot resource server. I don't know if this is sufficient. I can also mention the functions, what we need to touch, but most probably this would be something which we have to provide as data to the node listener to function properly. Right. This was small addition. This was this paragraph. Basically. Then the other kind of addition was the checkpointing, as we will as the CCI manager becomes the responsible component for CPU management. In that case, it has to provide checkpointing. So we have save and load functions currently, which will basically save the state, the store state in a. Yeah, we can do it similarly to CPU manager. We can have CCI manager state basically, and this is saved and loaded when we need it. This was another small change so that we can get checkpointing in. Then we were discussing how. Marlo, you are.
There's at least one person waiting to get let in.
Yeah, I have to admit somebody.
Yeah, I can't do that on your.
Let me admit. Yeah. Okay, so going back to the cap. Next kind of proposal was if we can to make the component, the CCI manager, completely self-manageable without the need to having any DRA kubelet drivers or kubelet plugins. We could, or there was a suggestion if we can basically handle the plain logic which usually which was used to reserve resources for a given claim and basically to free them inside the CCI drivers. And I was thinking as a first kind of iteration or possible interface, we could do that by taking our admittance remove container resource functions, where we add more or less the claim parameters to it. I have a little bit better view on that. You see it nicely in the gRPC definition. So this is very similar to node prepare resource. If you look in node prepare resource of DRA, it defined those four, and we can pull them in the admit kind of request, and this can help us more or less keep track of the incoming resource claims and do reservations. We will use also the resource handle as good way to pass the arguments. Basically, before we had the CCI spec, now we can just pass the resource handle, and that would be sufficient. And then similarly, we use remove resource request basically to free claims and deallocate information or deallocate resources for a given container. This was one suggestion how we could do that. I think it would be sufficient, most probably, for first approach. Any thoughts?
Yeah, I mean, I'd need to look in more detail about how this is actually put together, but just to be clear about what the proposal was last time was keep the same DRA architecture we have today. It's just that instead of what we have currently defined as the kubelet plugin for DRA, which returns a set of CDI devices, you guys can write your own variant of a kubelet plugin that has its own gRPC API, which is what you're presenting here, and potentially has a different set of calls that are made back and forth during different points in the container lifecycle in order to support CCI devices instead of CDI devices.
That's the point. We call them a little bit differently, the functions. We have a little bit more information, as we need some additional information for the containers and pods. But basically we have the admission function is very similar to, or holds some of the information what node prepare resource was having before, and our remove container resource basically it's we can maybe rename them to admit resource or something, but yeah, or this one it's a little bit for the I have resource container resource everywhere, but in admit I should do it consistent, most probably. Yeah, that's the main kind of change what we did in the CAP so far. I think other than that, we tried to address a lot of the other issues just at the end of the there's one final thing in the alternatives section at the end. We have this kind of annotation based approaches, just as suggested. We shortly describe them there. Right, so yeah, we will merge that to master, to our kind of master today, most probably, and then for all people interested, if you can take a look, we will send a link and give us some feedback when you have time, and yeah, then we can try to work towards merging it as officially. Yeah, that's today. It's a little bit shorter. I don't have too much other things. Yeah, but
I have a question, if possible.
sure.
Sorry if it's already answered. I was on vacation. So last time, on the last meeting that I I participated, I asked a question about like other pods. They are not those that are not referencing any claims, and they just request some kind of like some amount of CPUs and memory.
Right.
And you explained that those pods they will be also could be also scheduled to the same node when like this CCI driver runs. Is it correct?
Yes. Yeah.
And how, like in this situation, how we can avoid like double accounting? So I mean, like from one hand, the CCI driver would maintain allocations of CPU and memory, like in future, and it would be also possible, like if like
Right.
those pods that are not referencing, they are not using like this approach. They also would consume some CPU and memory resources. So how that would be synchronized?
Yeah, this is avoided through the so-called store. Basically, after making a call to the mission, we get the result resource set for the pod which was handled by driver, and we put it in the store. Basically, with some container ID resource set, and later, let's say you have another pod which was assigned to that node by scheduler. To get it assigned correctly to that node, we still have to consider the available resources. This was the point what I mentioned at the beginning, that for correct functioning of the scheduler, available resources has to be propagated down to the node listeners, or there is this kind of class available. And basically, to ensure no double accounting, the resource store has to be used. So basically, when new containers come in, they will be asking the resource store for available CPUs, and the resource store knows at any time what are the available CPUs. More or less, it will maintain a view of the available resources, which will be correct at any time, more or less.
But that would happen on kubelet side, right? Isn't it already late? So I was kind of thinking that some changes should be done like on scheduler side to avoid this kind of situation, that we actually schedule pod that actually cannot be served properly.
Right. This to avoid that, it's basically we added small kind of verification. I'm lost again. Yeah, here it is. I will show the codes in a second, but basically there is so-called pod resource server inside kubelet, which is this kind of node listener. So the pods, yeah, and this is called snippet of the pod resource server in kubelet. And it provides, or what scheduler does calls this get allocatable resources for each node. And
wait, sorry to interrupt, but the scheduler, the default scheduler doesn't. This information is consumed by other daemon set, which uses this data to publish the information about the resource availability into another object. This is at least the case for the NUM-aware topology-aware scheduling solution we were working at, and this was the recommended solution. But in any case, as best as I know, and I'm not sure this changed to the array. I think no, it didn't, but the scheduler is never ever calling the the node directly, never communicates to nodes. And I'm just mentioning the array because I don't know. I think it's very unlikely, but I don't know. So I'm leaving 1% option open.
I agree. So that there is basically this component is publishing somewhere this data basically periodically, and there is some listener on the scheduler side which pulls the data or receives new data from
This is up to you. How would you want to design the consumption if you need?
But we will not touch the scheduler, so we are more.
The thing is, if I understand the Bartosz concern correctly, and please Bartosz, correct me if I'm wrong, this is exactly the point. If you provide this data, but you don't change the scheduler is not aware of this data. So we are back to square one, and this, I'm not sure this actually answered the question from Ed.
If you provide the data on the server and the mechanism is the same, why shouldn't it work? It should work.
But okay, so the default scheduler doesn't need this data. The scheduler plugin, which is enabled in topology scheduling, actually needs to consume this data, have the intermediate representing actually the API object to represent this data, and then consume this data. But all of those steps are explicit. So if, and I really mean if, because I'm not up to date to the changes to the cap, so what I'm saying could be obsolete already. If you have a model like that already, then you will need changes to the daemon, which pulls this data to update the object, and to the scheduler plugin. If, again. If not, then I don't know. So I'm just pretty much telling what is the case for the NUMAR scheduler plugin.
In any case, in terms of DRA scheduling, which is covered by the controllers, this is not really relevant. This is relevant as soon as you turn on static CPU management. So if you have static CPU management and there are standard pods coming in with some guaranteed quality of service, this is when this actually becomes important. But in environment where you didn't have pods with static quality or with guaranteed quality of service and stuff like that, all the scheduling is covered, at least for the pods with standards with claims will be covered by the controllers and DRA. So one of the kind of requirement what we will have is for alpha phase, our kind of pods which will have claims don't get, or they will be using CPU management none, and additionally you will actually we would avoid specifying request limits, CPU request limits, and yeah, basically usually in the container spec you have request limits, and yeah, as the whole specification of how many cores you want and stuff like that is happening through the resource claim. So we would require that basically request limits are left outside or are not included in the pod spec. And in that case, basically scheduling it's handled by the DRA controllers. So
okay, that could work. Well, I think we can discuss in the cap itself and make sure it's okay.
I think this is maybe a nice simplification for alpha version. Later, when we have static kind of quality of static and guaranteed quality of service, we have to come back to this point. Take a look exact on the allocatable CPUs, allocatable memory, and if we need somehow to propagate the data further to the scheduler. Yeah, but for alpha, I think we are fine as long as our pods do not have requested limits. And yeah, in any case, we are not using static policy so far.
But even in this case, some pods would be scheduled to the same node, and they will anyway consume some CPU
They
and memory
will
resources, right?
Yeah, they can get scheduled on that node, but they will not they will be scheduled on resources which are in the shared pool.
Okay.
We have the similar to static CPU manager, they distinguish between kind of the exclusive pool, the shared pool, and yeah, so basically those pods we can put in the shared pool.
And this CCI driver would not actually work with those, with that pool, with shared pool.
It can work also with the shared pool. You have, if I switch to the cap, we have basically isolation level called shared. So if you want to put certain application on the shared pool, you can do that with that flag. But in that case, we don't care if they overlap because they are shared. It's known by contract that they can overlap.
Okay. Thanks.
Yeah, this was an addition we did to the cap, a little bit more specification of the attribute-based stuff and how a claim kind of integration can look like. That was added.
Okay, another question I would like to ask is about the situation when we have CCI driver and some DRA drivers. So how they would, I assume that they would be just like filtering claims by driver name or something like that, right? So to understand which actually claims should be served by a certain plugin.
Which driver? Yeah, by driver name, and we were discussing at the beginning, we can create a unique socket for the CCI kind of registration.
Yeah, but to be clear, I don't think that's necessary. I mean, just use the standard plugin mechanism. It's already separated, and so it's not even necessarily worth pointing out.
But I mean, Kevin, like all those plugins, they will be filtering all pods referencing any claim. So that kind of concerns me in terms of performance. So like if we are talking about some yeah, sorry.
My phone was ringing, so I couldn't hear you. Can you say it again?
I mean, like my concern is that all these DRA and CCI plugins would have to like filter out, would have to look at all the claims to actually get the claims they want to serve, right? And
no, I don't quite follow. I don't follow. So in the same way that, you know, standard DRA works, you know, I have my controller, and my controller allocates resources however it knows how to allocate resources based on being called out to by the scheduler, right? None of that changes in this world.
Yeah, I understand.
And then once you get down to the kubelet, depending on, you know, either CCI plugins or standard DRA plugins will have registered with the kubelet, right? And they have a specific name that's associated with them.
Yes.
And so we're going to have something that sits above our DRA manager that knows how to request for the standard DRA path or the CCI path based on the driver name.
Yeah, but wouldn't it like raise some like performance issues? Because like for CDI for these DRA devices, they are kind of it's the amount of pods referencing those claims are kind of like not that big, like in this case with CPU and memory. So I mean, and this
You're envisioning there's a lot more pods that'll be using
yes,
this mechanism than what we do with DRA. Is that your
yes,
concern?
yeah, and like this this code pass would be called much more frequent than now, so it potentially can create some performance issues.
Yeah. I mean, that was one of the initial arguments for keeping the CPU manager in the kubelet to begin with. But I don't see there being much more overhead doing this than if we were to, you know, turn any CPU manager into a plugin via any architecture. Right. The minute you decide to have this CPU allocation be done by a plugin and say that's the way we're going to do it going forward, I don't see being more overhead than that, unless I'm misunderstanding what you're saying.
It in any case, it's something which can be measured and seen. So
But would I mean, yes, we can definitely measure it, but I'm trying to understand, Ed, are you worried about there being more overhead than just the sheer fact that you have to call out to a plugin to make these decisions, or is there something more than that?
Yes, that so basically in case of like many claims, much bigger amount than for the devices. So basically, like let's imagine that like every pod scheduled to the node would be referencing some claim because it wants to use some CPUs and memory. And in this case, amount of queries to API server, because we need to, like for each claim, we need to query allocation results and parameters maybe. So some calls, so those calls, the amount of those calls, which will be much bigger. So that's my
because
concern.
the claim is not embedded in the pod itself. You have
Yeah,
to call out to the API. Yeah. I mean, that's definitely a concern. It's an overhead that would come from that.
Okay, so this should be somehow
Captured,
answered, captured, yeah, in the cap.
Say that this is potential, but at this point, the types of systems that are going to be doing this, right? They may have that tolerance.
we can just mention it. Basically, that this processing the claim will still require the connection, or within kubelet you still need to contact the Kubernetes API server for that. Until that is not optimized away, it's a limitation which is there.
Yeah, I think one of Ed's concerns too is just that because we'll be doing this a lot more often in the kubelet, that delays processing of quote unquote normal pods that don't need this mechanism.
But
It slows down everyone else.
if you have, but let's say you're deploying normal pods, they will not go through that path. So or they will not.
They don't, but pod admission is serialized, and so processing one pod and it taking longer means that next one won't be able to be scheduled or run until later.
This we might revisit in beta if there is some prioritization capability or prioritization space, if we can somehow overlap those two. But yeah, there are race conditions we want to avoid there. But most probably there is some space for doing better if we do some stuff asynchronously.
Yeah, we'll see. I mean, by design, pod admission is not and cannot be parallelized, but pod creation and starting a container and running it can be, in theory, although it's not at the moment. Yeah.
Yeah, we will mention it in known limitations, something like that. Then.
Until we measure it, we don't know the real impact.
And yeah, until it's measured, it's unclear. Right. Then yeah, anything else?
Not for me. I need to take a closer look at the changes that have been made here and go through
Yeah.
the cap again, but
Sounds good. Then yeah, we will give you some minutes back. Thank you for joining today.
yep, thanks. Bye.
Thank you.
Thank you.
Bye bye.